Hi, I'm Alan MacRobbie and welcome to Program 4 of Scopology. Now, today's going to be a little awkward, okay, because we've had questions from customers in the past about using an oscilloscope to measure the AC voltages in their house. And the first thing is that why would you want to do that? You might as well just use a DVM and make sure it's a true RMS DVM and get a good reading from that. But against my better judgment, since we've had so many requests about it, we're going to talk about it anyway. So before we get started with hooking up all of these probes to this test piece of equipment here, let's go to the board, which is over there, and we'll talk about some concepts that you need to know before we get started. Okay, this is the first of two diagrams we're going to look at today. The first one here is about floating an oscilloscope, and this is generally an unsafe practice, and it's done often by using some kind of isolation transformer that does not carry the ground through to the secondary, or by somebody cutting off the ground pin on the scope's power cord. So we don't want to really do that, and I'll explain why. Consider the device under test here with two terminals, T1, T2, and they're both floating above ground. T2 has some voltage that's significantly above ground, and this is where the scope's ground lead is going to. If the scope is floating, then the whole metal chassis and everything that you can touch on the front of the scope is now at that V1 voltage. So the scope chassis is at the same point here. And if the operator comes along and somehow grounded or standing in water or something and touches one of these points on the scope, there's going to be a fault current that flows through him, and he's going to be uncomfortable or damaged because of that. So that's what this can result in. That's why we don't recommend it. So we advise either using a scope that has an isolated input structure, or by using a differential probe, and we'll talk more about those later. And the last option that's good is to use either an optical or transformer coupled voltage isolator. Okay, so now we'll go on to the next diagram. Okay, two things I want to mention here. Back at the breaker box, you're going to find that the ground and the neutral buses are wired together. So that'll help you make more sense of what you're going to see subsequently. The other thing is, be careful how you unattach things after you've already attached them. We just used this meter here to measure from T1 to T2, and T2 was ground. So that was fine, except that the fella here disconnected the ground first and left the high side still connected. Through the meter, we're going to find something very close to the high side voltage right here, and if he's grounded, he can get a tickle out of that. So just try to be careful when you're detaching and attaching things. I can't go through all the different scenarios, so use your common sense and make sure you don't do something like this. Okay, so now we've reviewed that, we can get started hooking up some things. One of the things that I'm going to be mentioning from time to time from here on out through the rest of these sessions is the CAT ratings on some of our products. The scopes usually have an indication as to what category that they're rated for. For instance, this scope here says it's rated for Cat 2. The probes are also rated, and it's important to look at them because, for instance, these two probes look very much alike. They're slightly different model numbers. One of them, the one on the left here, is rated for Cat 1. This one on the right is rated for Cat 2. So I'll explain more about what the category ratings are as we go forward. But at this point right now, what we want to do is we want to take an AC voltage measurement in kind of a Category 2 situation, because we're going to be looking at the primary side of this transformer that belongs to this little wall transformer DC supply thing that I broke open. So what we're going to do is we're going to hook up the scope with a stock ×10 probe. Now this is a switchable probe, so you have to make darn sure it's in ×10 before you hook anything up. And the other thing I wanted to say about wall outlets is wall outlets in houses quite often can be found to be miswired. So if you haven't checked it with a meter or an outlet tester, I wouldn't try doing any of this without knowing exactly what you're doing. Now, in this particular case, I know exactly what I'm doing, so it's not a problem. Okay, so I'm going to hook up my ground to the neutral. Since this little transformer here doesn't even have a ground, I'm going to then probe the hot with this probe here set on times 10. Okay, and you can see that I get a nice waveform here, a little bit, well, you can see the distortion, and considering all the reactive loads that are attached to your local transformer, it's not surprising to see some distortion on the waveform. Okay, we're going to just press the stop button here. I can take this down and we can look at the waveform. We can see that it has a 321 volt peak-to-peak voltage, and it's also got an RMS voltage of 115 volts, and this scope also has a frequency counter in it, so it's operating at 59.99 hertz. So that's pretty good. That's what I would expect to see. Now, if you're concerned about somehow switching the probe to times 1 when you're in the midst of all this, that wouldn't be good for you or the oscilloscope. So one thing that we can suggest is that you can increase the capacity or the ability of the scope to measure higher voltages by switching to some higher capacity probes in terms of voltage. We have here an example of a times 100 probe. And this probe here is actually rated for Cat 2, same as the scope input, and this, incidentally, same as this probe here. So what we're going to do is just take a look at it real quick. I'll get the scope running again. Now you recall that you have to compensate probes, and I've already done that for this particular channel. So we're going to hook up this probe here. And what's nice about the scope is that it has an accommodation for times 100. So I can move that right down there. You can see that. Select that. Turn off the menu. Now I can hook up my probe ground to the neutral, and I can probe here and increase my volts per division. There's a nice time right there. Okay, let's just stop that. Now, well, at any rate, we were able to see again about 325 volts peak to peak, 113 volts RMS, frequency 60.01 hertz. The interesting thing to note is that if this is 325 volts peak to peak, then what the voltage is, it's being input to the scope, is only 3.25 volts. So that's increased the capacity of the scope. It's increased the safety of the measurement quite a bit. And the only thing that we can do to become any more safe on this is to operate the scope on battery or to use a differential probe if you're not sure exactly of what you're dealing with here. So anyway, we'll get into that in subsequent programs, and thanks for watching.